describe a combined variation. This is a combination of all the variation types that we had learned, namely direct, inverse, and joint. Remember, for direct, we have varies directly. That would be y is equal to kx. For inverse, varies inversely or inversely proportional to, we have y is equal to k over x. And for joint variation, we have more than two variables involved or two quantities involved. If we have varies jointly, we can have y is equal to k x z or more variables. These are some of the combined variation real life examples. W varies jointly as x and y and inversely as z. Now, if we're going to write this is equal to varies jointly, so we are going to have the constant of variation k with the variables x and y because they are joined. And inversely, we will put that in our denominator z. This is now our formula for or the equation for the given mathematical statement. Now let us derive for the value of k. So to solve for k, we have w is equal to k xy over z. Okay? Remember, we are just going to derive this from the equation that we have. So we'll cross multiply, we'll have this. So wz is equal to kxy. And we need to remove or eliminate the two other variables beside k. So we will multiply both sides with 1 over xy. Then this will be cancelled because xy over xy is equal to 1. And what we have left on the right side is k times the 1. So that would be k. And on the left side of the equation, we have 1 over xy times wz will be wz over xy. This will be our formula for the constant of variation. That is just the same when we rewrite it as k is equal to wz over xy. This will help us solve for the value of the constant of variation. These are the terms that we will use in combined variation. Varies directly as b. That would be a direct variation. And inversely, we put it in the denominator c. For the second given, we have y varies jointly as x and z and inversely as w. That would be y, constant of variation, jointly x and z, and inversely as w. That's how we're going to write it. The volume of gas varies directly as the temperature and inversely as the pressure. So let us assume variables. Volume of a gas varies directly as the temperature T and inversely as the pressure over P. Number of phone calls, C, per day between two cities has found to be jointly proportional to the populations of the two cities, P1 and P2, and inversely proportional to the square of the distance D between the two cities. So let's take C varies jointly with P1. Don't forget the constant of variation, P1 and P2, and inversely proportional with or to the square of the distance. So we have the D squared. Then that is our equation.